Hey guys, Mrs. Dan's here again. So today, your video really will be just doing some of your homework problems with you. It's not a preview into tomorrow's lesson. Tomorrow we're actually just practicing everything that we learned. So I just want to remind you about the elimination method. We know that we want the x's lined up, the y's lined up, the equal signs lined up, and the constants lined up. And if everything is lined up, then we look to make sure that the coefficients of one of the variables are opposites. And we could see that x has coefficients that are opposites. So this is one of the easy questions where we're just going to put a plus sign and add, and the x's get eliminated because it makes 0x. And here we're left with 6y equals 18. And then, of course, we would divide both sides by 6 to get that y is 3. Remember that the solution to a system is the point that they have in common. And a point has an x and a y coordinate. So right now, all I know is the y. Remember, in order to find the x, we just take this number and substitute it into either one of the equations. It really doesn't matter which one you choose, so I will just choose the top equation. So 8x plus 5 times 3, because I'm replacing my y with the 3, equals 19. And this should help me find the value of x. You shouldn't have to watch me solve this. You should be able to do it on your own. The only thing that some people make a mistake on is right here. When I divided both sides by 8, this does not turn out to be 2. 4 over 8 is a half. Please be really careful with those basic concepts. So the answer is 1/2, 3. Notice it says that we have to check if there is one unique solution. So I will go through the checks on this problem with you. The rest, though, you're on your own. I like to really organize myself, so I call it check number 1. And I rewrite the first equation. And then I substitute in my x and my y values that I found. A half times 8 is 4, 5 times 3 is 15, and 4 plus 15 is 19, so my first check worked. Remember, to make sure that it's the point that they have in common, you have to make sure that that point works in the other equation. So I'll call it check number 2. And in place of the x, I'll put a half. In place of the y, we put 3. We just hope that that calculates to be a -1. -8 times a half is -4, and -4 times 3 is -1. So it did work. This is full credit on your quiz. So I'm not going to do number 2 with you. I'll tell you the answer, though. The answer you should get is 3, 0. You have to do the work, and you have to do the check in order to have credit on tomorrow's homework. Number 3 is one like what we did in class where everything is lined up. Unfortunately, we don't have opposites. So I'm going to choose to just multiply the bottom equation by a -1. I see that if I multiplied the x by a -1, I'd have a positive 7x on the top and a negative 7x on the bottom, and therefore I have my opposites. Remember, you multiply the entire equation because we say that we're using the multiplication property of equality, which means that both sides of the equation must be multiplied by that same number. My top equation doesn't change. My bottom, everything gets multiplied by a -1. And this is one of those interesting answers. Since I have opposites, I can add these. And the x's get eliminated. The y's get eliminated. But over on the right side of the equal sign, I have a -6. If the x's and the y's are eliminated, doesn't that mean I have 0? and 0 does not equal -6, so this has no solution. Remember, lines, these are lines, that show no solution actually are parallel lines if we were to graph them. So if I were to get this into slope-intercept form and graph, I would have a pair of parallel lines. They do not share any points. I am going to start number 4 with you. You are going to finish it on your own, though. Something I want to point out is that the x's are lined up. The y's are lined up, the equal signs are lined up, the constants are lined up, but I don't have opposites. It's not as easy as number 3. It's not just a negative that I need. The numbers aren't even opposites, right? 8 and -6, they're not opposites. 14 and -7, they're not opposites. But what I notice is that if I multiplied the bottom equation by a 2, then my y's would be opposites, because this would be a -14y while the top is a +14y. So you are choosing the number that creates opposites. It's different for every problem. It's even different for different people in the same problem. You're trying to create opposites. So this is me starting you off. The top equation stayed the same. The bottom equation is now a -12x minus 14y equals -20. I do have opposites, so I can add these together. I get -4x, the y's are eliminated, equals -16. Divide both sides by -4. X is a +4. After I find out what x is, I do have to go back and find what y is. You're going to finish that without me. And since there is one solution, you're going to do 2 checks. So expect to see number 4 worked out thoroughly, you finding the y value and doing the 2 checks. The x value is a 4. If you find your y value correctly, you should get a -2. But you must show that work in order to get credit tomorrow. Number 5 is the one that I really want to focus on. Everything's lined up, but I don't have opposites. And it's not as easy as number 4. I can't just like multiply the bottom equation by something. There isn't a whole number that I can multiply 3 by that makes it the opposite of 5. And there isn't a whole number that I can multiply 9 by that makes it the opposite of a 4. So there are some times that we actually multiply both equations. If I multiply the top equation, you can just watch this for a moment. You don't have to write anything down just yet. But if I multiply the top equation by a 3 and the bottom equation by a -5, do you notice that my x's will be opposites? I'll have a 15 in the top and a -15 in the bottom. The y's won't be opposites, so I'll be able to solve for y and get a value. Now, I said don't copy this yet because there are plenty of things I could have done. What if I decided to multiply the top by 9 and the bottom by 4? Now, do you notice I'd be eliminating the y's, right? This would be a 36, while the bottom would be a -36. So really, you can eliminate either variable that you choose. Some people get themselves into a habit, and when they have to multiply both equations, they just always eliminate the x because it's the first thing they see. So I am going to go back to doing 3 and -5. So if you want to start writing this with me, you can. So I wind up getting 15x plus 12y equals -90. In the bottom, I get -15x plus 45y equals positive 90. Now I have opposites, so I'll add and eliminate the x's to get 57y equals 0. So when you divide both sides by 57, y is 0. Now I take this and substitute it into one of the original equations. I'll just pick the top one. This is a 0, so I'm not even going to write it down. I get that x is negative 6. So the answer is negative 6, comma 0. Of course, you have to do your 2 checks. I'm not going to finish these checks with you. I think you should be able to do them. Remember, it has to be in the original. And when you do a check, you are substituting both x and y in at the same time. Maybe I will just finish it. I'm almost done. So I get negative 30 plus 0. Negative 30 equals negative 30. Check. And then number 2. I get negative 18 plus 0, which really is negative 18, equals negative 18. Check. So number 5 was probably the trickiest that elimination gets, where you have to multiply the top and the bottom equation by different numbers to make opposites. I'm not going to do number 6 with you, but we'll talk about some strategies. There are plenty of ways that you could do this. So really, Joe is saying that the 2 systems have the same solution. So here's our first system. So he's saying that the x and y value that goes with this first system is the same as the x and y value that go with the second system. So you have to determine and state whether you agree with Joe or not. So one thing that you could do is solve the first system, find the xy pair, solve the second system, find the xy pair. If they're the same, then you say, yep, they do have the same solution. Of course, there are other things that you can do, though. If he's saying that the first system has the same solution as the second system, you might want to solve the second system and then just check those answers in the first system. You do whatever feels best for you, but you have to determine and state whether you agree with him or not, and it says justify your answer. Remember, justify means prove what you're saying. So you can do some math work, you can use some words, you can use a combination of math and words. You do what's best. And I'm signing off. I didn't keep it too long, hopefully. At least I got through your homework with you this time. All right, see you tomorrow. Bye.